So last class, we left off looking at solving percent proportions and percent equations. Oh, I don't like that. What we're going to be looking at now are some applications of that, some more specific applications. We're going to be looking at sales tax, commission, discount and markup, percent increase and decrease, simple interest, and compound interest. So there's a lot that we're going to be looking at, but what I'm going to show you is how we can, that echoes terrible. I don't know why it's echoing. I have not gotten over it, Kalika, so it's still real fresh. You're going to figure it out? I don't know. Anyway, what I'm going to show you guys is how we can use what we've already learned in those two sections that we did on Tuesday and apply them to what we're doing here. On D2L, we'll be posting our formula sheet for Unit 4. So you guys are going to get a bunch of formulas, but you're not going to get any of these formulas. So you're going to have to figure out a way to understand these different formulas so it doesn't feel like you have to memorize all of them. Because if it feels like you've got to memorize them all, you're going to really struggle. But what I'm going to try to illustrate today is that they're all exactly the same as that percent equation that we did the other day. I need to put headphones in. Sorry. The first thing we're going to look at are solving applications involving sales tax. Everything that we do today should feel very much like stuff we've experienced in our real lives. We've all purchased things with sales tax. Whether or not we've been in a job where we've earned commission, we probably understand the concept of commission, but all of this stuff is something that should be pretty relevant to our everyday lives. So starting with sales tax is tax based on a percent of the cost of your merchandise. So to determine your sales tax, you're going to take the tax rate for that particular area and multiply it by the price. What I want you guys to see is that this sales tax is the same as the amount the tax rate is going to be a percentage and the prices are base. So this is exactly that percent equation that we set up last class. But now we're calling the amount and the base something very specific. Okay? We're calling it sales tax, we're calling it price. The new iPhone 11 Pro costs $1,189. The sales tax rate in Denver is 8.31%. Compute the amount of sales tax. So to determine the sales tax, we're going to take that tax rate, and when we're using a percentage inside of a mathematical equation, what do we want to do to the percentages? Convert it to a decimal. So what is the decimal equivalent of 8.31%? Close. You just said the same thing. I said 0.0831. How did we get that? Yeah, we take that percentage and divide it by 100. The other way to do it is just to move that decimal 2 to the left. So we're taking that tax rate and then we're multiplying it by the price. The price was $11.89. What is our sales tax? So like you kind of had that question in that answer. When we're talking about sales tax, it's money, right? The most accurate we can measure money is to the hundredths, to 2 decimal places, because that's the nearest cent. So whenever you're dealing with an application and you're solving for a dollar amount, you're always going to round to the nearest cent, which is 2 decimal places. So 98.81. Mercedes, you're giving me that look.
I accidentally on the 1189.
Mm-hmm. Oh, gotcha. No, you're good. Yeah, like I think that was what, when I bought my iPhone, that was what it like was retailed at. I don't know if that's actually the price of it, but that's what AT&T charged me. So, and that's what I understand, but that's okay. Anyway, how would we determine the total cost then? Think about it again. The total cost, like, so what the individual consumer is going to spend on this phone is going to be what? What is it going to be exactly? How are we going to find it?
Add 1189 plus 98.1. I mean, 81.
Yep. We're going to take that cost, that price that they have, and we're going to add the sales tax to it.
I was doing this yesterday. I was on Alex a little bit last night. It's like, ooh, now I really know how much 20% will be off.
Yes, you do. Yes, you do.
I'm like, well, if I
What's the total cost for this iPhone? $1,287.81. Good. Questions? Mm-hmm.
really, if you thought, I know.
Oh, that's not nice.
I imagine like the lady like. See, because like I'm always so scared because like I hate spending money, really frugal about it. So when I'm like trying to treat myself, I can't get past prices. But if I start like adding up how much it's really gonna be, I'm like, oh, okay, I can spend that.
Yeah. Well, all of these applications are they're really important, and we do use them all the time. We're setting them up a little bit more formally as an algebraic equation right now, but you guys have solved these types of problems when you're out shopping. You 100% have. The sales tax on a new snowblower is $21.50. If we know the tax rate is 6.7%, what was the price of the snowblower before tax? So we're going to take our percentage and we're going to rewrite it as a decimal. So what's 6.7% as a decimal? Good. Now we know the relationship between price and sales tax. The sales tax equals the tax rate times the price. Which pieces of this equation are we provided in the problem? The sales tax and the tax rate. And it asks us what's the price before tax, so that's the unknown, that's our price. So substituting in our known values, the sales tax is $21.50. The tax rate is 0.067, and our price is unknown. How do I solve for X? What was the price of that snowblower before tax? $320.90. Again, we're always going to round to 2 decimal places when we're dealing with dollar amounts. Questions? A DVD of Jurassic Park sells for $15 on Amazon. The sales tax is 90 cents. What is the tax rate? Katrina, what are you saying?
I was just talking out the equation. So we know the price of the DVD is $15. We know the sales tax is 90 cents. We're going to convert that to decimal, right?
Do we need to convert the sales tax to decimal?
Because it's already in a decimal.
Well, and it's a dollar amount. So the only thing that we're converting to a decimal would be a percentage.
Oh.
So what does our equation look like? Very good. Good. And to solve for x, what would we do? Divide both sides by 15. Good. What does x equal? Good, 0.06. Now, what does the question actually ask us to find? Which should be expressed as a percentage. By multiplying by 100, we're converting that decimal back into a percentage, which is how we talk about these tax rates. If we convert to a percentage, do we need the percent symbol? Yeah. Yes, absolutely. 6 and 0.06 are not equal values. 0.06 and 6% are. Questions? Again, thinking back to that percent equation that we looked at in section 6.6, I think. Amount equals percent times base, right? The amount is the part of the whole that we're comparing to the whole, right? It usually is near the word is, before the word is, and the base is usually what follows the word of. When we take that out of the context of the generic form, we're still using that exact same formula. Your sales tax is the part of the whole, isn't it? That's your amount. Your base is that original price, and then the percent is your tax rate. So we're not creating a new formula. If you guys can recognize that, bless you, if you can recognize that we're not using any new formulas here, it's going to feel like a lot less memorization. Otherwise, you're going to feel like you got all these formulas that you need to memorize, and that's not really where you want to be at, okay? It's the same equation over and over and over again, the same formula. It just now we're using different contexts, and so we have different words that we fill in for that amount and the base. Next, we're going to look at problems involving commission. Commission is a form of income based on the percent of sales. Kalika, you probably get paid on commission, don't you? Do you know what your commission rate is?
I'm 200 shy of 20%.
So Kalika makes 15%, like her income is 15% of how much she sells. You're selling the Cutco wear, right? So her paycheck depends on how much she sells. So it's in her best interest to try to sell as much as she can, right?
I get paid no matter what.
Mm-hmm.
I get an $18 an hour base.
Yep.
And if I make more than that on my percent, I get paid my commission. But if I get paid more for just my hourly I'm always getting the better of the two.
Oh, that's nice. Okay. So it is really common for positions like sales positions to earn some type of a base salary and then earn additional money on top of that. Think about what you're doing. You are selling the product for some manufacturer. The more that you sell, the more money that company makes. So that's a lot of times why there's that incentive to sell more by paying commission. So the total commission that a person can earn is equal to the commission rate times your total sales. Again, that's your amount. Your commission rate is a percent. And your total sales is your base. It is exactly the same as that percent equation we saw last time. Diane sold a home for $245,000 and earns a commission rate of 4.5%. How much commission did she earn by selling the home? The amount of commission is equal to the commission rate. And how are we going to express that commission rate?
Is it 245K the base?
It is. Good. How are we going to express that 4.5%? 0.045?
I don't have to keep thinking like 0.0. 3.0. I would start thinking
Okay. So yeah, in the medical field, that leading zero, that's the 0 point. That leading zero is really important because when you're handwriting prescriptions or medical orders, without that zero in front, it's not necessarily clear that it's a decimal. Nobody writes a whole number with a zero out front. So if the zero's out front, whether or not you can see that decimal point, it's indicative that it is a decimal. And if you can't see it, then it's, let me follow up with whoever wrote this order to make sure that I know exactly the amount of medication that I should be administering. So 100%, yes, it absolutely does make a difference, like a life difference. But we're not doing that in this class. So if you didn't put the leading zero, that's fine. It is a good habit to get into. I'm really good about it in some classes and clearly in this class very lazy. So, but it is a good habit to be in, or a good habit to have. So what is the commission on this home? $11,000 and $11,025. Does that seem reasonable? Do you guys know any realtors? Your mom's a realtor? So now you could have these conversations with her and see, like, I mean, if you know what she's getting paid on commission, and that is variable when you're a realtor, there's a lot of negotiating that happens between realtors on what commission they're going to get. But you could figure out how much money she's making on the homes that she's selling.
You're like, Mom, you're lying. Wait, 20K. Give me 5.
Give me 5. A sales rep for a pharmaceutical firm makes $50,000 as his base annual salary. In addition, he makes 5.6% commission on all sales. How much does he need in total sales if he wants an annual salary of $104,000? Reread the problem to yourself. What do you think we need to find first? Katrina, what'd you just type in your calculator?
Well, I converted the percentage.
Okay, so we know we're eventually going to need to do something with that percentage. So that percentage is going to be, I know. Katrina's so good about it. She's been trained.
So wouldn't we have to act like his base is 104?
No, his base is always going to be $50,000. So what do you want me to subtract? Good. So this annual salary is going to equal his base salary plus his commission. We know his annual salary, or what he wants his annual salary to be. He wants it to be $104,000. We know his base salary is $50,000. And by solving this equation, by doing that subtraction, Kalika, we're figuring out how much commission this person needs to make in order to have that overall, that annual salary of $104,000. Does that make sense so far? Okay, so what is the commission that this individual needs to make? $54,000. We also know that the commission is equal to the commission rate times the total sales. His commission is $54,000. What's his commission rate? 0.056. And we don't know how much he needs to sell. That's what we're trying to find, right? We're basically setting a goal for this individual in terms of sales to ensure he makes the income that he wants to. How do we solve for X? Divide by 0.056. What does he need in total sales? It was a big number. What is it? $964,285. All right. When you do, you know. Yeah. Does this seem reasonable? Well, this is not the, I mean, we're not talking about Diane anymore. Let's think about the application that they're talking about. They're talking about pharmaceutical sales, the selling of drugs, legal drugs. Yes. Guys, how much do we know about like pharmaceuticals? It's a huge income, like a huge industry. It makes a ton of money. Okay. So that idea of selling about $1 million shouldn't be all that wild, right? Now, the other thing we need to know is that, or at least recognize, the commission that he makes is a percentage of that total sales, right? And it's only about 6% of those total sales. So it's a pretty small amount. Well, if he's going to make $50,000, $54,000, the amount he's got to sell has got to be a pretty large number, right? Because that $54,000, which is a lot of money, is still just a very small percentage of that total sales. What questions do we have? Okay. Applications involving discount and markup. So a discount is the amount that we save on an item. The amount that we save is equal to the discount rate times the original price. Markup is the increase in the cost of merchandise, often made by retailers in order to make a profit. Your markup is equal to your markup rate times the original price. Do we recognize that every single one of these formulas is exactly the same? It's literally just different names for the 3 items. Like there's 3 terms in the formulas and we're just giving them different names. But it's exactly the same every single time. The more you recognize this, the less it's going to feel like you got to memorize. An importer uses a markup rate of 35%. What is the markup on a leather chair that has a manufacturer price of $1,100? Using that formula for markup, it's the markup rate. What's the markup rate? $0.35.
385.
Yes. You're way ahead of me. So it's the markup rate times the original price of the chair, which was $1,100. Zaida, what was that? 385?
Yeah, I got 385.
So that's the markup. How do we then determine what the retail price is?
Add.
No, just kidding.
What are we going to add?
385 plus 1,100.
Good. $1,485. When you go to purchase something from a store, like in this case, a chair, the store bought that chair from somebody else. They're buying it for a lot less than they're selling it to you because they need to make money off of it, right? That's how that store stays in business.
I got ripped off.
What's that?
I got ripped off then.
What do you mean you got ripped off?
Because like you said, that they paid cheaper to actually get the product and we pay more.
And that's true, but you don't have the ability to go to the manufacturer and order it. The manufacturer's probably not going to sell a single sofa. I don't know that, but my assumption would be that that's the case, right? The manufacturer wants to sell 100 sofas. And Wayfair is like, yeah, we've got the capital, the dollars right now that we can pay you for 100 sofas. They front that money and then they sell that sofa for more than they paid for it, and that's how they start making profit.
So
You have to go to
So-
like an overstock.
And even then, you're not going to get the manufacturer price because everybody's out there trying to make some money, right? So
how, I was like, I'm trying to see how we can like, would it be sales tax is 1485 times 0.06?
yes. Why is it not $1,100?
Because
put yourself in this situation. You pay sales tax on what the purchase price is, right? The purchase price is not $1,100. You can't buy this leather chair for $1,100. You can buy it for $1,485. So you're going to pay sales tax on that entire $1,485. So the sales tax is 0.06 times $1,485. So how much are we going to pay in sales tax? So what do we have to pay to go home with that leather chair? What is the total cost? How are we getting that? The retail price is $1,485, and then we pay our sales tax of $89.10. $1,574.10.
Do you guys know that
I hope so.
Furniture Row, they sell beds full of horsehair and sheep, like the Queen has in England? They last for like 20 years. But it's like $20,000.
Okay.
There's one in the store.
Fun fact.
I didn't know. And, you know, they go based on credit, so we get have good credit. You never know.
Find the discount rate for this headlamp that's on sale at REI. This was actually on, this was on sale in the last few weeks because I pulled this from REI's website.
So the total price is the $34.99.
So what we're trying to find is the discount rate. So how much is this on sale for? When we go to a store, it typically says what? When something is on sale, what does it say? Give me any example. Yeah? Bingo. They say, oh, these are 50% off, right? So you have the original price, and typically they'll give you that discount rate. But I'm giving you an example here where REI hasn't given us the discount rate. They've given us the original price, but they're saying, nope, now you get to buy it for $13.73. So that seems like a really big discount, right? But how much of a discount really is that? What percentage? I know personally when I've been shopping on websites, I will look for things like if I'm looking for a pair of winter boots, I want to find the ones that have the biggest discount, right? It's great that a pair of boots that are only 20% off are cheaper. I want the pair of boots that's 80% off. Then I feel like I'm getting an even better deal, right? Because I'm getting a larger percent discount. So a lot of times you got to figure that out yourself, like we're doing in this example. So what do you think we want to do first?
What I did is I just kind of wrote out the equation first and then just filled in
What equation did you start with?
the amount.
Okay. Okay.
Well, we're trying to find the percentage, right? So that means the percentage would be X times 34.94.
So let's keep going with what Kalika had suggested. So what's our amount? Okay. The percent is our unknown. And then what's our base? Okay. How do we solve for X? What do we want me to divide? Point what? 0.36. Yeah, I think 39 actually might be correct. Oh, okay. So can you give me more than 2 decimal places? You got point is the 5th, what's the 5th digit? So 24. Okay. So that's our decimal for X. What does X represent though? So we should be converting this to a percent. Multiply by 100. We have not done anything wrong, but my question for you is this answer reasonable based on the context of the problem?
No.
Okay, why? Nothing has been calculated incorrectly. I would have stopped us if we had done something wrong.
50% off.
Bingo. If we look at those two prices, the $13.73 is less than half of that original price of $35, right? So we know that the discount is actually more than 50%. So can we figure out then what we have found? No, it is a percentage, but
We get the decimal wrong?
nope, nothing has been calculated incorrectly. But the way that we set it up, we set up to solve for a percentage that isn't actually the discount rate, right? And we observe that because we know that the discount rate should be more than 50%. Based on those two prices, we know that it's more than 50%. So let's go back to that equation that we set up. We didn't do anything wrong, but we've approached it from a little bit different of a way. And I'm going to set it up in another way once we're done. But I like going through this technique because I want you to observe kind of where your mind is starting and understand where your mind is going with that idea, right? With that setup. So if I look at this, 1373 is some percent of 34.99. That's what we found. We found what percent of 34.99 is 1373. So we figured out what percentage of the original did we actually pay. Okay, so how, Kalika, can you say what you just said out loud?
We found the percent of what we spend on what we save.
We found the percent of what we paid.
Yes, that's what it says.
Sorry, it's hard for me to process that. We found the percent of what we paid, not the percent of what we saved. So how do we figure out the percent that we saved?
Well, what I did was subtracted, so 100 minus 39.
Good.
So we saved 76. Oh my God, how did you figure that out? 100%?
Yeah.
Minus the 39 that we spent.
Yeah.
So we saved 60.7.
We only paid about 40% of the original cost.
Yeah, I didn't get it until she started poking and prodding at it, where she said the percent.
Yep.
I'm still wrong.
That one's alright.
I'm going to set this up in a different way, and it's a little bit longer, but maybe it'll be a little bit more obvious what we're doing. Okay.
Let me just copy this.
Yeah, sure.
Well, I don't know what's wrong. I'm not falling asleep, but my eyes were just closed. And then but I can hear everything you're saying.
Oh, that's good.
So I'm not sleeping. I'm just like this. I don't know why.
Because it's Thursday.
I'm so like, you're exhausted. It's just her voice. It's just so soothing. It's just like,
My voice is so soothing.
no, 'cause like,
I've never heard that before.
I was like this.
Katrina, did you get it? Okay.
I'm good.
All right. So let's look at this problem in a different way. Okay. So we're just going to go over here. We're trying to find the discount rate, right? Well, I have a formula for the discount, and the discount is equal to the discount rate times the original price. This is what we're trying to find. That's our X. Do we know what the original price was? What's the original price? Yes, $34.99. Look, I speak Spanish. In order to solve for that discount rate, in order to solve for this, I need to know what this is. I need to know what my discount was. The discount is the amount of money that they're going to take off of that original price, right? Can we figure out what the discount is? Let's go back to our advertisement. Can I figure out how much of a discount I got in terms of dollars?
Yeah.
Subtract.
Right.
Yeah. We're going to subtract $34.99 minus $13.73. And that's how much money we're actually saving, right? And that's what your discount is. It's how much money you're saving. Katrina, we good?
Yep.
All right, so someone tell me what the discount is. $21.26. So now let's look at this equation. We've got 21.26 equals X times $34.99. How do we solve for X? Good. Divide both sides by $34.99. What is X?
She's usually ahead of game.
Ooh, I don't know. That doesn't sound right. So it's 0.0, or sorry, guys, let's try to focus. 0.607. What's the fifth digit? Okay, so 0.6076. Okay.
How do you know how far out to go? Because I got that answer, but I rounded it up 0.61.
I might tell you.
Oh.
So you have this answer in your calculator, but we're solving for X, which is what? What does X represent? A percent. So we want to write it as a percent. So before you do anything in your calculator, multiply that answer by 100. So that all you have to do is press times 100. And then the directions tell you to round your answer to the nearest hundredth, your final answer. So now that it's in a percentage, it's easy to see round to 2 decimal places. So that's 60.76.
I can understand it, you know what I mean? It's just like, it's repetitive and I don't have that. Yeah.
here's my speculation. Okay, I don't necessarily have evidence of this. My speculation is that when you guys are working on the homework, you'll probably get most of the questions right. You probably won't write a bunch down. You'll just go to your calculator, because in real life, when you're at the grocery store or you're shopping, you're not writing an equation, are you? You're just looking at the numbers and manipulating the numbers, and you kind of have some sense to how to do that. And that's how you figure out whatever it is you're trying to find. The struggle that's going to be now is taking that intuition, right, what your brain wants to do, but keeping a record of it. So like I mentioned last time, you guys are required to set up an equation. So you have to have an unknown somewhere. So what you might do in the homework, try to solve it however you think, like whatever your brain is like, okay, let's grab the calculator, let's try doing it, and write that answer down. When you guys type in an answer in Alex and you get it right, the problem doesn't automatically go away, does it? Like, you can still look at it. So if that's what you want to try, just doing it however your brain is like, yep, grab your calculator and type this, this, and this, do these operations, and you get it right, then I want you to pause before you go to the next question and actually start trying to set up the equation for it. And see if you can set up an equation that allows you to solve for the unknown and you get the same answer, right? It is wonderful that we can intuitively figure this out without keeping track of our work. For the exam, I need to see you keeping track of your work. You need to set up that equation. So if you can get to the answer first, then start working on, okay, how do we set this up with an equation? Okay. That's something that you're going to have to train yourself to do, because our experience, our real life experience, we haven't had to do that yet, right? Our entire lives, we've just grabbed our cell phones or whatever calculator we had and started, doing multiplication or division. You're still doing that. Now you're just stating it as an equation first. Okay. Okay. Any questions?
Yeah.
You're fine.
So we could have easily gone into the discount equal discount rate times original.
But you have to be thinking like, okay, that formula is talking about the amount of discount, like the dollar amount of discount compared to the discount rate compared to the original price. We didn't have, the information wasn't given to us explicitly what the amount of discount was. So we just had to figure that out.
Sure.
Yeah, which is what we did in green here, this subtract, ooh, stop. What we did right here, that's subtraction. Okay, let's keep going. Percent increase, percent decrease. When you're computing percent increase or percent decrease, you are comparing the change between two amounts to the original amount. It's okay. So when we think about change, how do we determine change? Let me give you an example to give you like something to work with. If I talk about the change in temperature, how would you determine the change in temperature if I gave you two temperatures? You'd subtract. Change is subtraction. So for percent increase, it's the amount of increase, or so how much it changed, divided by the original, multiplied by 100. Again, because we're finding a percent now, that's why we multiply by that 100. The percent decrease is the amount of decrease. Either way, you're just finding the change. The difference is whether or not the change is going up or the change is going down. That's how we'll identify it as percent increase or percent decrease. After a raise, Denise's salary increased from $42,500 to $46,000. What was the percent increase? Round to the nearest percent. How do we know it's going to be percent increase other than the fact that it says it? Yeah, her salary got bigger. It increased. How much did her salary increase? How did you get 3,500?
42,547.
What's the original amount? That 46,000 minus 42,500, that was our 3,500. So that is the amount of increase. We're dividing it by the original. And then you take that ratio and you multiply it by 100 to convert it to a percentage. Katrina, what'd you get?
I couldn't get it back.
Oh.
8.235.
Oh, round to the nearest percent.
So 8.254. Obviously that's wrong.
Just 8%.
Oh. I think I'm having a hard time with the whole,
So the language of those rounding directions,
yeah.
you'll practice them on Alex. You'll review them in the test review as well. To the nearest percent is like saying round to the nearest number of books, round to the nearest number of people. It is the same thing as saying round to the nearest whole number.
Is that you? Oh my god.
Do we need a break, guys? Can we get through one more example and then we'll take a break? Okay. That'll be a good place to stop. So in the next one, we want to compute the percent decrease between day 2 and day 3. So looking at my graph, day 2, the stock price was $21. Day 3, the stock price was $20.58. What's the amount of decrease?
21 minus 20.
Yeah, well, 20.58.
And that's gonna be
42 cents. Is that correct? So then the percent decrease equals that amount of change, 0.42, divided by the original. What was the original?
the original, would that be the 21 plus 40, 20? 40? Well, it's because they have 2 days to
Okay, so we've got day 2 and day 3. Which do you think is the original?
Oh.
Day 2. So the original is the one that was first before any change happened. That's your original. Karen, what'd you get? 2% decrease, good. Any questions? The next thing we're going to look at are interest applications. So interest is money that you earn in a lot of cases, or extra money that's owed. Can anyone give me some examples of times in their life where they have either earned interest or been charged interest? Yes, when you purchase a car, your savings account. So those are two examples. The example of the car, you have to pay additional interest, right? So it's more money that you owe. So it's kind of like a negative. But in the savings account example, that's money that you're actually making. Okay. We're going to talk about two different ways of calculating interest. We're going to look at simple interest and then compound interest. So simple interest is money earned based on only the principal. So the principal is the original amount that's being invested or borrowed. So we have two formulas here. I equals P times R times T, and A equals P plus I. Looking below, we have a list of what those variables mean. So I is the amount of interest. P is the amount of your principal, so that's your initial amount, whether it's borrowed or invested. R is your annual interest rate. Again, we talk about interest rates as percentages, but when we substitute them into formulas, we'll convert to a decimal. T is our time, and I do want to make sure that we're very clear that time is always measured in years. And A is the total amount in the account, whether the account is a savings account or the account is a credit card bill, right? It's the total amount. Simple interest. So let me talk a little bit more about simple interest before we go into some examples. I like to use the following as kind of an idea to give you guys some idea of what simple interest is. When I was a little kid, my brother would always spend all of his money and then he wouldn't have any. Whereas I was really good about saving money that I had earned, whether it was allowance or money that I had gotten for my birthday or something. And I remember my brother asking me if he could borrow some money. And being the good sister that I am, I'm like, yeah, sure. I'm also little, so I'm not that smart at this point. So what I decided was, okay, you have to pay me back. He's borrowed $20 from me. You have to pay me back $25 at the end of 2 weeks. Okay. Or I might say, every 2 weeks that it takes you to pay me back, you're going to pay me another $5. Okay. So that extra money that my brother's paying me back, that's my interest, right? So I'm kind of making money off of lending him money, which is exactly how credit cards work, just so you know. We'll talk about that once we get to compound interest. But that amount is a fixed amount, right? It's not changing every 2 weeks. It's the same amount every 2 weeks. And that same amount was based on how much I lent him. If I lent him $50, maybe I'd say, okay, you're going to pay me $10 because $50 is a lot more money, right? If I've lent it to him, I can't spend it. So in my opinion, it's justified to charge him more interest. This is an example of simple interest where the amount of interest is based only on the principal, okay? So here's some examples. Suppose that we invest $2,200 into an account that earns 5% simple interest. How much interest is earned after 7 years? So our equations, the first equation, I equals PRT, gives us the formula for calculating interest. P is our principal. What is the principal in this formula or in this problem? 2,200. R is our interest rate as a decimal. What? 0.05. Excellent. And T is the time in years. 7.
So would it be like 2,200 times 0.05 times 7?
Very good. Yep, just straight across, just multiply. 2,200 times 0.05 times 7. I just got 700. 770? Okay. No, I mean, I could just have a typo. Oh, I know why. I can see exactly why. Because I didn't write the problem right in my problem, in my work. Can I borrow your pen? I don't know what this number is. Thank you. Sorry. So what's the total value of the account after 7 years?
Then you take 2,200 and add 700, right?
Yep. So again, if we look back at those formulas, the amount is equal to our principal plus our interest. So that future amount or the total amount in the account, which is what we're looking for, is equal to the principal, 2,200, plus the interest, so after 7 years, that initial investment of $2,200 is now worth $2,900 or $2,970.
Well then, is that 2970 after 7 years?
Yes.
Or for
No, after 7 years. At the end of 7 years, that's how much money is sitting in that account. If $800 is invested for 2 years and earned $40 in simple interest, what was the simple interest rate?
we did it 8 equals?
What do you think?
Because I don't have a rate.
That's what we're trying to find. So that's going to be our unknown. In the last 2 problems, in part A, the unknown was I, the amount of interest, and in B, the unknown was the total amount. The unknown in this next example is our interest rate. It's R.
So R equals.
We're not going to have R equals because we don't have any formulas for R equals, do we? Which formula are we going to use? Z? I equals PRT? Do we know what our principal is? Yep. We don't know what R is. What's T?
2 years, yeah, right.
And what's that 40?
40 interest.
That was how much interest was earned.
Wait, why would 40 be oh,
Because my formula is I equals PRT, right? That's 40 is our interest.
Yeah, so 40 equals 600 R times 2.
What's 800 times 2?
16. We need to divide.
Mm-hmm.
She's writing it down. She has.
No, I'm not. I'm multiplying it. 2.5%.
So when we first divide, we get R equals 0.025, but because we're finding an interest rate, we want to convert it to 100, or sorry, convert it to a percent. So that's 2.5%. Questions? You okay? You sure? Okay. So the next thing we're going to look at is something called compound interest. Compound interest is when the amount of money earned is based on the principal and any interest accrued over the life of the account.
So like the complete total amount with interest included plus price.
Yes, but that's not different than what we were looking at with simple interest either. So compound interest is actually way more common. You guys probably in any type of account that is earning any kind of interest, whether the interest is good or bad, is probably using compound interest. Okay. So let's think about for a moment a credit card. Who in here has a credit card? Okay. Some of us. if you don't have a credit card, are you pretty familiar with how that whole process works?
Yeah.
You charge something, so you're not paying for it out of your own personal bank account. You're not paying cash for it. Basically, you're having Mr. Chase or whoever is your credit card company, having them pay for it. And you're saying, okay, Mr. Chase, I'll pay you back. It's like a loan. That's exactly what it is. And so you can buy whatever you want right this moment. But you have to pay it back. Now, Mr. Chase is providing a service to you by saying, here's the money right now. Maybe I don't have the money right now, but I need it, right? Maybe I don't have the money to get new snow tires, but I know that I need snow tires. So Mr. Chase is like, here, I'll let you borrow this money and pay for those snow tires so you can have them right now. Just pay me back. But Mr. Chase is not just going to let me borrow money for nothing. They're going to charge me an interest rate for borrowing it. So depending on how long it takes me to pay it back, I'm going to pay more and more money. So let's use an even more simplified example. I decide at the beginning of the year that I really want this new pair of shoes. They cost $100. Okay? Are you guys with me?
Yeah.
Okay. So if the new pair of shoes costs $100 and I charge it to my credit card, let's say my credit card is going to charge me 10% interest. If I go 1 month without paying my credit card bill, what's my new bill going to be?
That was $110.
$110. 10% of that initial amount borrowed is $10, right? It was 10% of 100, so $10. That's why I chose these easy numbers. Okay. So I'm being charged $10 in interest, but I still have to pay the original $100 back. So now I owe $110. Well, another month goes by and I haven't paid my credit card bill. What's my interest going to be at the end of that second month? What's 10% of my bill? What is my new bill?
So it would be what's 10% of 110? Is that what you're saying?
So I borrowed $100. Oops. If I'm charged 10%, my interest is $10. So my new bill is $110. Mm-hmm. What's 10% of 110? $11. So what's my new bill at the end of my second month? Let's say I go another month without paying my credit card bill. Not 13.
No, yeah, 12. Sorry, we're at 11.
12, 10. I'm finding 10% of that bill. So what's my new bill? 132.10. Oh, sorry, thank you. 133.10. So let's just quickly look. That interest is not the same every single month, is it? Why not? Why is my balance growing? Because you're thinking of the original amount borrowed plus what? Plus the interest, right? This 110 right here is my bill, my principal, right? That same word, that principal, plus $10 of interest. And now I'm being charged interest on the principal plus that interest.
So is your minimum amount typically like your interest charges? Is that how they get you? I mean,
No, I think that if you were to look at your credit card statement, I think your minimum, actually, I would be willing to bet that your minimum payment is less than your interest charges.
Yeah.
Because, I mean, think about it.
They're wanting you to keep your money in there, make money off.
Exactly. If I finally pay the credit card company back after 3 months, how much money has the credit card company made off of me? No. At the end of 3 months, how much?
$35
No. 30, exactly $33.10.
Oh yeah, huh?
I borrowed $100, and at the end of 3 months, I'm going to pay them $133.10, which means the credit card company just made $33.10 off of me. For lending me that money, they've made $33. The longer it stays in there, the longer it takes me to pay them back, the more money they're going to make. So yes, when you think about that minimum payment on your credit card bill, it's going to be less than those interest charges, so that the next month they're making money off of the interest that they've already charged you.
My dad wanted me to take out $10,000, and I was like, hell no. That's gonna be a long time to pay off. Yeah, I understand. Really?
So to calculate, the amount in the account that's being compounded, A is equal to P times 1 plus R divided by N, raised to a power to an exponent of N times T. Now, there's only one new variable in this formula, the N. The N has to do with the number of times that that account is compounded per year. So how many times a year are they going to reassess how much interest or what the balance is and what the interest should be at that moment? In the case of a credit card bill, when do they reassess what the interest should be? The amount of interest that you pay. Monthly. At the end of every single month, they say, okay, well, this is what they haven't paid back, so this is how much interest I'm going to add to this bill. They do that every single month. Kalika, you mentioned you have a savings account that you earn interest on. Do you know how often you're getting interest on that?
I don't. I just kind of notice when it sometimes deposits like a few cents.
Yep, it like has like little deposit of exactly like a few cents, right? I think mine is like always so tiny because I don't have any money in savings.
How much I have in my account.
It does, because it's based on that balance, right? Most savings accounts compound quarterly.
And then if you make over like $5 or something, $0.08 or something.
So you can put on your taxes. Yep.
I was like, this is $10. $10, $10. I mean, I don't know about you, but I, you know. So,
Well, because you're making money, just like you have to pay income tax, that interest is income, right? It's money that you're making. So that's why they do that, because then you have to pay income tax on that. It's a bummer. But so N is that new variable. It references how many, or represents how many times per year your account's going to be compounded. Now, if I use this first formula here, that gives me the total amount in the account.
total amount in the account.
Yes. This second formula now allows me to solve for how much interest was either earned or charged. Right? In this example over here, we were able to see that at the end of 3 months, we had been charged $33.10 of interest. And that's because we took this future amount and we subtracted that initial principal. And that's how we figured out how much interest was there.
You said the second one is interest, right?
I is interest, yes. That was earned or charged. Interest can sometimes be a good thing and sometimes it's a bad thing. In the case of any type of loan, not a good thing. In the case of a savings account or stocks or something, it's a good thing. It's a really good thing. Suppose that $2,200 is invested at 5% interest compounded semi-annually. Find the total amount in the account after 7 years. This problem looks very similar to the one we just did. What's different about it? It says it's compounded semi-annually.
That's 2 years. Twice a year.
Twice a year. Yep. N is always how many times it's being compounded per year. So N equals 2. Good. What would it be? What would N be if we were compounding quarterly? Quarterly. 4. How many quarters are there?
I do my taxes on my own. There's 4 quarters.
So if the account is compounded quarterly, N would be 4. Compounded monthly would be 12. Compounded weekly, what would it be?
Like 52 weeks.
How many 2 weeks are in a year?
How many weeks is it?
52.
52?
Yes, there are 52 weeks in a year. What if it was compounded daily?
365.
So that means every single day it's reassessing that balance and then reassessing interest. Fun fact, if you happen to come across an account that is compounded daily, it is only compounded 360 days in a year, not 365.
Why? See, that's what I was
It's called the banker's rule. So
What is better, simple or compound?
we're gonna investigate that question right now. So the question was, what's better, simple interest or compound interest? So let's investigate that with this example, because it's the same principle, it's the same interest rate, it's the same amount of time, right? So my amount is the principal, 2,200 times 1 plus my interest rate. What am I going to plug in for R?
0.05.
Good, 0.05. We always want to convert a percentage to a decimal if we're plugging it into a formula. Divided by N is raised to the power of 2 times T, which is 7. I'm going to simplify this a little bit because I do want to type this in my calculator, but I don't want to have to necessarily have too many parentheses.
Oh, because it's NT.
The only thing I'm going to simplify right now is the 2 times 7, that exponent. We can type this whole thing into our calculators. We're going to type 2,000 times, and then we're going to open parentheses. We're going to type 1 plus 0.05 divided by 2 and close your parentheses. And then we're going to use the exponent key. So I think most of us have that caret. Yes, divide by 2 and then close your parentheses. And then, Katrina, on your calculator, do you have a caret for your exponent key? Like a little up arrow?
No, I have you said exponent. Is this the X and then
The little box, yep. So you're going to press that one. Everyone else is going to put the caret. And then we're going to type 14. No, you don't need to close any parentheses, and just hit equals. What did we get? I did. Oh, in every single problem I did 2,000 instead of 2,200, so I have no idea.
Yeah, I heard you say 2,000, and I was like, I know. But I thought you just kind of like.
I just misspoke, but I see 2,200, and every single problem that has that 2,200 I evaluate with.
Watching that research and not paying attention.
It must be. 3,108 and 54 cents. Okay, let's compare this to what we found when we used simple interest. Ooh. What does that mean?
Which one's worse?
You tell me.
Equals 3,108.
When we use simple interest, we ended up with an account balance of $2,970. When we compounded semi-annually, so twice a year, we ended up with $3,108.54. So depending on the context of the problem, one is better than the other because we're investing money. That's like a savings account, which is better. The compound interest. If this were a loan, which one is better? Simple interest. Because the simple interest is going to be a lesser amount than the compound interest. Because the compound interest, you're earning interest on interest, right? Mm-hmm. In this case, we're earning it twice a year. Questions?
So the 3,108 you're earning 2 times a year, or is that the total for the year?
That's the total amount at the end of 7 years. Right? A is the total amount after a given amount of time. So at the end of 7 years, in the first account, we made $2,970. In this new account, my new balance is $3,108.54. So when you guys are thinking about opening up savings accounts, it is really in your best interest to investigate how they're going to do their interest, what your interest rate is, right? If you have a higher interest rate, that means you're going to make more money on your investment. I'll tell you right now, you're never going to find a savings account with a 5% interest rate. Most of them are at like 8.8%, less than 1%. They're very small. Banks are not really in the business of giving you money. So Kelly's booking a flight to visit her family in Florida over the holidays. Southwest is offering a deal that when you open a line of credit with them, or for when you open a line of credit with them, Kelly decides to apply for the credit card and puts her $500 $549 flight on it. The credit card has a 19% interest rate. What will her credit card bill be in 6 months if she doesn't pay off the purchase? So this is actually real life. I was booking my flight for the holidays and I was like, oh, they had this promotion. I didn't do it, but they had this promotion and I looked at the interest rate for that credit card. So this is a real application. Like, this is like, 2 weeks old. This is recent.
So we would use the A equals P formula?
So I have some hints here. My first hint is how many times a year are credit cards compounded?
Monthly?
12 monthly. So N is going to be 12. My next hint is how many years is 6 months? Remember that the variable T in these applications is always measured in years. So if they give you an amount of time in months, you need to convert to years.
What would it be if it said 3 months? 0.3?
Nope. So if T was 3 months, how many months are in a year? So 3 months divided by 12 is 0.25 years. That's actually a real basic conversion. And after we get through this lesson today, we're gonna start our conversation on conversion. So we'll do that even more. Okay. So A, the amount, my credit card bill, is gonna be my principal. What's the principal? Yeah, it's the original amount that I borrowed. What's my interest rate? Try again.
0.06.
What's the interest rate stated in the problem?
It's 19%.
19%. That's okay. I'm not sure. You saw the other 6 in the problem. The other number of 6. So 0.19. N is how many times it's compounded per year, which we identified is 12. And that's going to be raised to the power of n, 12 times t, which is 0.5. Before I start typing this in my calculator, I'm going to simplify that exponent because I don't want to be doing an operation in an exponent. What's 12 times 0.5? Good. So it's 549 times 1 plus 0.19 divided by 12
Now, is there any
raised to the
way
power of 6.
to like do the insides first
Sure.
and then
So
take that big number on the inside with 549 and you'll still get the answer?
So you can break this down. You don't have to type it in all at once. This is order of operations. The first thing we want to do is what's inside the parentheses. So if we're going to do that, let's do what's inside the parentheses only, which is 1 plus 0.19 divided by 12. Are we all doing this? So what's 1 plus 0.19 divided by 12? 1.0158. Did you add 1 to that? No. Oh, no. It's not 1 plus 0.19 totaled divided by 12. It's 1 plus 0.19 divided by 12. So in terms of the order of operations, if I'm working inside the parentheses first, really we should be doing that division first and then adding 1. But our calculators are sophisticated enough that we can just type this whole thing in at once. Okay, so we should have inside the parentheses 1.015833333333. We're not going to round this. We're going to leave this whole value, and now we're going to raise it to a power of 6. Because in the order of operations, it goes parentheses, then exponents, then multiplication and division, addition, subtraction. So we're going to take this and we're going to raise it to the power of 6, and that gives us 1.09884. And what are we going to do with this number? Perfect. Okay. But yes, you can break it up. You just have to do the order of operations. Inside the parentheses, take that and raise it to your exponent and then multiply.
You're going to have to know that for the HESI. You won't get a calculator like this. You get a basic one. So
you need to know your order of operations.
Yeah, they will have a calculator.
Isn't that what we learned in the beginning?
Yeah. Yep.
Like the beginning.
Yeah. No, it wasn't the beginning time. Maybe feels like that, but no. So the amount that I'm going to have to pay back at the end of 6 months is now $603.26. Based on this information, how much interest was I charged over that 6-month period? Good. So the fee for me borrowing this money for a period of 6 months is $54.26. Yeah, almost. That's crazy, isn't it? Which is exactly why it's so easy to get into credit card debt, because of that compounding of the interest.
Well, I thought it was low. So it's high.
I mean, I don't know. I don't really want to pay an extra $54 for a flight. 19%, but 19% is actually, it's really not. For a credit card, it's not very high. So I think that's a pretty standard credit card rate. I think I have a credit card with REI, and I think it's like 22%. So that's one you pay off right away. Guys, do you have any questions?
No.